Chapter 11 is on alkanes and cycloalkanes. Nomenclature means naming compounds, so we're going to learn how to name alkanes in this chapter. We're going to be following a set of rules that we call IUPAC versus learning how to name common names. So I'll expect you to know how to use IUPAC names, which is a systematic method of naming compounds. It's a set of rules that was put together by the International Union of Pure and Applied Chemistry. So it's chemists from around the world that came up with a set of rules so that we can name compounds. And if you're in, let's say, Germany or the United States, you're going to name this compound exactly the same way. So for example, IUPAC name is methanol. This is a common name, formaldehyde. So you've probably heard of formaldehyde, but we're going to be learning rules that you'll follow in order to name compounds based on their structure. So we're going to start with alkanes, where they don't have any branching occurring. And what you're going to do is count the number of carbons in your compound. You're going to use a prefix to tell you how many carbons you have, and then the ending -ane. So the ending -ane means that we have single bonds between hydrogens and carbons, such as what I'm drawing down here. I have all single bonds. That tells me I have an alkane. So alkanes will always end in -ane. The prefixes you need to know are listed in this chart here. The prefixes tell us how many carbons we have in our alkane. So for example, if I have one carbon in my compound, the prefix is going to be meth. Just like what I drew on the previous slide, I had one carbon. It's an alkane because I have all single bonds to carbons and hydrogens. The name of this compound would be meth to tell me I have one carbon, and the ending would be -ane, methane. Then 2 carbons is eth as your prefix, 3 is prop, 4 is bute, 5 is pent, 6 is hex. So I remember when I was taking organic chemistry when I was back in school a long time ago, some of them made sense to me. Like I know 5 means pent, like a pentagon has 5 sides. Hex is 6, like a hexagon has 6 sides. Oct, like an octopus, has 8 legs. So some of the prefixes made sense. Non sounds like 9. Dec, like the decimal system, is based on tenths. Or in the metric system, deci means 1/10. So that made sense to me. The ones I had problems were the first 4 and trying to remember meth, eth, prop, and bute. So I came up with a sentence for myself to help me remember that. And it's Mary eats purple berries. And that was just to help me remember the first letter in those words. That's why I got purple berries on this slide. To help me remember those prefixes for carbons 1, 2, 3, and 4. I had a student who added on to my sentence, which I thought was very clever, to help remember all 10 prefixes. They added on please, help, her, on, new, diet. So you can have compounds that have more than 10 carbons. We're only going to learn how to name compounds with 10 carbons at the most. So you need to know these prefixes for carbons 1 through 10. So this is something it's important to memorize those. Okay, so we can go ahead and name some compounds. So we have an alkane with 1 carbon, all single bonds. So the ending again is -ane. 1 carbon, the prefix is meth. This one I have 2 carbons, the next one. So 2, the prefix is eth, and the ending is going to be -ane. The next one we have 3 carbons, so that prefix is prop. The ending is -ane. So again, Mary eats purple. If we wanted to have 4 carbons in our next compound, we can just draw the condensed structural for that really quickly. And then the B would be my berries, for Mary eats purple berries. And that tells me the prefix is bute, and the ending is -ane, butane. Now we can have alkanes that have branches. We're going to learn how to name those. So the first thing you're going to do is find the longest continuous chain of carbon atoms and assign that as the parent name. So our longest chain of carbons here is 4 straight across. So we are going to name our parent first, and with 4 carbons, that's going to be called butane. So if we just had 4 carbons and hydrogens, it'd be butane. But we have this branch, so we're going to learn how to name the branch. Okay, so now to name when we have these groups that are attached, that we can also call branches. I also sometimes like to call them children because they're going to be attached to the parent. So our parent, again, we had 4 carbons in this straight chain. So our group or our branch or our child is attached here. So you need to also learn how to name the branches or the children or the groups, whatever you'd like to call them. So this table shows us some group names. Now I want you to know how to remember to know the names of the first 5 that are listed. The ones down below, you don't have to remember. We're going to find some ways around remembering those, so we'll look at an example. So the prefixes were the same as before. We have the meth, eth, prop, but, and pent. But the difference here is if it's a group, you add the ending YL. So methyl, ethyl, propyl, butyl, pentyl, etc. So again, it corresponds with the number of carbons. So methyl means there's 1 carbon, ethyl is 2 carbons, propyl is 3 carbons, butyl is 4, and then pentyl would be your 5 carbons. So in this compound, we have 1 carbon in my group, so the child or the group name is methyl. And we're going to name that as the prefix, so it goes in front of it, because if you have children, you know as a parent, children always come first. So methyl is my child, it goes before my parent. So the name we have so far is methylbutane. So our next rule to finish naming our compound is to show us the location of where that group is attached. And again, I like to think of, I have a parent, I want to know where my child is, so I'm going to show the location of that child group. So how you're going to do that is you're going to assign numbers by counting from one end of the chain to the other end. And you're going to assign numbers when you count in your chain so that the group is going to get the smallest number. So here we can count from one end and we have 1, 2, 3, 4. The other option we could do is if we wanted to count from the other end, 1, 2, 3, 4, because remember it's a chain, it's 3-dimensional, we can flip this around. But you're going to assign the numbers, so you always can only count from one end to the other, and you're assigning the numbers so the group gets the smallest number. So in this case, if I count from left to right, my group is attached at carbon 2. If I were to count from right to left, it would be at carbon 3. So the rule says we need to have the lowest possible number where the group is going to be in my carbon chain. So once I pick one direction of counting, I cannot use the other direction. So the name of my compound we have is methylbutane. The location of where my group is attached at carbon number 2. So the 2 goes in front of the name. Again, that's the location of where the methyl group is attached. And when you're naming compounds, if you have a number, you put a dash between a number and a letter. So here I have, it's not 3-methylbutane if I were to count from the other end of the chain, because that wouldn't be the lowest possible number. Name the following alkanes. So first thing we want to do is find the longest continuous chain of carbons. So in the first example, if we go straight across, we have a total of 5 carbons. The prefix for 5 is pent, and then the ending, because it's an alkane, all single bonds to carbon and hydrogens, we have pentane. Now we have a group attached. The group has 1 carbon, so the name of our group is methyl. Again, because it's a group, we have the ending YL. We want to show where that methyl group is attached. So we can count our carbon chain. It's always a good idea to count it from both ends so that you can make sure you have the lowest possible number. So I'm counting left to right and now right to left. And you want to go where the group is the smallest number attached to the carbon in the parent. So that's going to be our choice at the top at carbon 2. We're not going to use the numbering at the bottom. So we would call that 2-methylpentane. The one below, if we go straight across here, we've got 5 carbons, so we have pentane again. And then our group, right here, we have a CH3, so we have a methyl. And in this case, we want to count from both ends of our chain. And in this case, it doesn't matter. Both the methyl group is going to always end up at carbon number 3, no matter which direction we count. So this would be 3-methylpentane. So these first two compounds are very similar, but it's the location of what that methyl group makes them different. So they have different structural formulas. These two compounds would actually be isomers because they would have the same molecular formula, and you can tell by naming they have different structural formulas. 2-methyl is different than 3-methyl. So if you name them, that may help you with that. So let's look at the one at the bottom. Our longest chain of carbons we have here is 6, so that would give us hexane. And then the group attached in this one has 2 carbons, so 2 carbons is eth, and because it's a group, it's ethyl, so our child's name is Ethel. And then we want to show the location of where the ethyl is attached, so we can count the carbons in my parent. And I always like to get in the practice of counting both directions, just so I can make sure that that group is attached to the smallest one. So the one in red at carbon 3 is where ethyl is going to be attached at the smallest number to the parent. So we have 3-ethylhexane. You also may be asked to draw the structural formula of an alkane. So in this example, we have 2-methylheptane. So again, we need to know our prefix hept. That means we have 7 carbons. And it's an alkane, so we know it's all single bonds. So I'm going to go ahead and draw 7 carbons. And then I'm going to attach a group at carbon number 2. And it doesn't matter if my group is pointed upwards or downwards. And again, a methyl means a carbon with 3 hydrogens attached, and then it's attached to my parent at carbon 2. The last thing when you're drawing structural formulas is you want to show every carbon always has to have 4 bonds. So we're going to saturate it with hydrogens because it's an alkane. So that's the last step you want to do if you're drawing a compound, is make sure carbon does have 4 bonds and it's attached to the hydrogens. So you may have more than one group attached to the parent. Just like a parent can have multiple children, sometimes we have parents that have twins or triplets, so they have identical groups. So if you have identical groups attached to the parent, we're going to use some Greek prefixes. So this you need to remember as well. So if you have 2 of the same group, we're going to add another prefix in front of the name for the child, which would be di. If you have 3 of the same group, you use the prefix tri. 4 is tetra and 5 is penta. So you want to remember these prefixes as well. So let's name the following compounds. The first one, we have 4 carbons in a row, so that is butane, our longest chain of continuous carbons. And then we have groups attached. We have 2 CH3. So here is an example where we have some twins, 2 of the same group. So the group is called methyl. And when you have 2 of the same group, you put that additional prefix in the front. So we have dimethyl. And then we want to show the location of all of our groups. So just as if you were a parent, you want to know the location of your children, you want to know the location of both of them. So we can count in, again, our parent chain from both ends of the chain, and then assign the location of the groups to the smallest number. So in this case, it's going to be in the blue numbering at carbon number 2. So we're not going to use that one. And both of our groups are attached at carbon 2. So we have to show the location of both of the groups. So I put 2,2-dimethylbutane. And if you have 2 numbers, you put a comma between the numbers. So in nomenclature, comma between numbers and a dash between a number and a letter. The one below, 4 carbons, is our longest chain, so that is also butane. And then the names of our groups, we've got 2 methyls, so that's going to be dimethyl. And then the location of these, we can number our chain, and in this case it doesn't matter which end we start with. Both of our groups are going to be located at carbon 2 and 3. So it's 2, 3-4. 4-dimethylbutane. Now, parents sometimes have multiple children. The children do not have to be exactly the same, so you don't always have twins or triplets. You can have different kinds of groups. So if you have more than 2 groups attached, then you have to put the group name in alphabetical order. Okay, so let's look at the example to help us understand. So 2 or more different groups, we are going to put those in alphabetical order. And then it says don't include the di or tri when alphabetizing. You still include the di, tri, tetra, penta when you're doing the name, but it's not going to be for alphabetizing. So let's see what that means in this example here. So we find our longest continuous chain of carbons. And that, if we count across here, we have 1, 2, 3, 4, 5, 6, 7. 7, the prefix is hept, and it's an alkane, so we have heptane. And then we have some groups. So we have 2 methyls, and then the other one we have has 2 carbons, so that's an ethyl. So as far as putting them in order, we look at alphabetical order that E comes before M in methyl. So ethyl is going to be named first, and then the methyl. But because we have 2 methyl groups, we put dimethyl. So this is where I wanted to point out, we still include the di, but if you were to alphabetize with D, D would come before E in the alphabet. So that's the part where it says don't include for alphabetizing the di. You do include it in the name. So we have ethyl dimethylheptane. And then all these rules just keep carrying over. We have to show the location of where our children or our groups are attached. So we're going to number our parent chain, and we're going to number it so the groups get the smallest number. And again, once you number from one end to the other, that numbering scheme needs to stay the same. You can only number from one direction to the other. So if we look at the red from left to right, we have groups at 4, 5, and 6. If we do the blue numbering at the bottom, we have groups at 2, 3, and 4, which means we have to use the numbering scheme from the bottom, 2, 3, and 4. So ethyl is attached at carbon 3. So we have 3-ethyl, and then our methyls are attached at 2 and 4. So we put 2, 4-dimethylheptane. So our name of this compound is 3-ethyl-2,4-dimethylheptane. Okay, let's name this compound below. So if we go straight across here, we can see our longest chain of carbons. We have 1, 2, 3, 4, 5, 6, 7. But then we end up with this group that is one of the group names I said you don't have to remember. So there is another way we can name this without going straight across. So the previous examples, we always went straight across to have the longest chain. But if we go do a little dip like this and count our carbons, we have 1, 2, 3, 4, 5, 6, 7. So that was the same as what we had before. We had 7 if we go across, or we can go across with 5 drop down for 2. We still have 7. So 7 carbons is heptane. Either direction we go, we have 2 ways we could have a longest chain. But the thing when we did it this kind of curved fashion, now we have groups that we know how to name. Okay, so our groups we have up here at the top, we have an ethyl, and then we have a couple methyls. So that's why I was saying you didn't have to learn how to name this one group, this sort of clunky group at the bottom, is we can name our compound that we know how to name these groups. So let's do our groups in order. Again, we have methyl and ethyl, so E comes first in the alphabet. So we have ethyl, and then we have 2 methyls, so we have dimethyl. And then we want to show locations of where the groups are attached. So I can start at the bottom of my longest chain and go up across. There's my 7 carbons. Or I could count from left to right. Okay, so I'm going to look where my groups have the smallest. So in the green numbering, I have groups at 2 and 3. If I were to use the blue, it would be 5 and 6. So we need to go with 3, and 2 in the green numbering. So for ethyl, ethyl is located at carbon 3. We put the 3 in front of the ethyl. And then in front of my dimethyls, they're both at carbon 4. So I end up with 3 dash ethyl dash 4 comma 4 dash dimethyl heptane. Okay, let's name this compound. Your first instinct, based on what we've done before, again, is maybe going straight across. So if we go straight across, we have 1, 2, 3, 4, 5, 6, 7 carbons. I want you to get in the practice from counting all possible ends of the chain, because I may make these compounds and kind of twist them around. So that's one way. If we cross, we have 7 carbons there. But let's see if we can count any other way where we have more than 7 carbons. What if we come across here and drop down? Let's see how many carbons that is. So we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have more carbons. So you always have to make sure you find the longest chain. It may not always be directly across. So with 8 carbons, oct is 8. For our alkane, we have octane. Now we're going to circle our other groups. We've got an ethyl, and then we have a couple methyls. So alphabetically, the ethyl is going to come first. And then we have 2 methyls, so we've got dimethyl. And then we want to show the location of where the groups are attached. So we can count from one end to the other. We're going left to right first. And we'll go back the other way, starting at the bottom, going upwards to carbon number 8. Okay, so now we want to see where our groups are attached. If we look at the blue, we have the ethyl attached at carbon 4, and then we have a methyl at 5 and 6. So we have 4, 5, and 6. If we go with the green numbering, okay, with our green numbering, we have a methyl attached at 3, and then a methyl at 4, and our ethyl at 5. So 3, 4, and 5 are smaller numbers than 4, 5, and 6. So that's the numbering scheme we want to use. We're not going to use this blue numbering. So ethyl is attached at carbon 5, and then our methyls are attached at 3 and 4. So our compound's name is 5-ethyl-3,4-dimethyl octane. So haloalkanes are when we have alkanes containing carbon and a halogen. The halogens in your periodic table are in column 7. We've got fluorine, chlorine, bromine, and iodine. So in order to name an alkane with a halogen in it, you're going to name your halogen as a group. Just like we did with our alkyl groups, the alkyl groups is carbon and hydrogens. This one we have a halogen, which will be in your compound. So in order to name a group that it contains a halogen, you're going to change the ending of the element name, for example, bromine. You're going to change the I-N-E to O. So bromine becomes bromo. We just dropped that ending, I-N-E, and added an O. Chlorine, drop the ending I-N-E and add an O, we get chloro. Fluorine becomes fluoro. Iodine becomes iodo. So you need to know the names of these 4 groups of the halogens. All your other rules for naming your alkanes are the same as what we've done before. Name the following compounds. So here we have an alkane that has 4 carbons. So in order to name that one, 4 carbons would be bute, ending ane for butane. And then we have a group attached, Br. So Br is bromine, and as a group, its name is bromo. So just like before, your group is your child. It goes in front of the parent's name. And we also want to show the location of where that bromine is attached. So if we count right to left, it's attached at carbon 2. So we have 2-bromobutane. Versus if we went left to right, it would be at carbon 3. So we want to have the smallest number. The one at the bottom here, we've got 5 carbons in our chain. So the longest chain of carbons with 5 is called pentane. Our group that's attached is a Cl. Cl becomes chlorine, becomes chloro. And where it's attached is at carbon 1, 2, 3. In this example, it doesn't matter if we go left to right or right to left, it's going to end up at carbon 3. So we have 3-chloropentane. So let's name these two anesthetics. So let's start with the one on the left. We've got one carbon, so the parent name is methane. We have 3 chlorines attached, so chlorine becomes chloro as a group, and because there's 3 of them, we put trichloro. Common name for this one is chloroform. You don't have to know the common name, but just because you've probably heard of that before as an anesthetic, and that's what this picture illustrates up above here. Now the compound on the right has 2 carbons, so the parent name is ethane, when we have 2 carbons as an alkane. Now we have some groups attached. We have a Br, which is bromine, that becomes bromo, and we have a chlorine, which becomes chloro, and we have 3 fluorines, and each of those are called a fluoro. So we want to put those alphabetically in order. So we have B first in the alphabet, so we've got bromo, and then comes chloro, and then comes fluoro, and we have 3 of them, so it's trifluoro. And then we want to show again where the children are located. So in this case, our options, we have 2 carbons, which one's going to be 1 and 2. So carbon 1 is going to be the one that alphabetically gives the groups the smallest number. So the carbon on the right is going to be carbon 1, where the bromine is attached, because that's smaller in the alphabet, or first in the alphabet, compared to the fluoro. So putting our numbers in here, we have 1-bromo, and then we have 1-chloro, and then at carbon 2, we have our 3 fluoros. So we end up with 1-bromo, -1, -chloro, -2, 2, 2-trifluoroethane. And that is also known as halothane, which is an anesthetic. Cycloalkanes are when we have single bonds between our carbons, and those carbons are connected in a ring. So for example, down below here, this would represent my carbons are attached in a ring, and it's an alkane, so we have all single bonds to carbon and hydrogen. So this compound down below that I'm drawing right now is called cyclobutane, which we're going to learn how to name these in just a moment. But just want to show you another way you can represent it is with a line angle drawing. And in a line angle drawing, your angles represent the carbons. So each one of these angles here, my 90-degree angles, represent the carbon. And the lines represent my single bonds. And then what's not shown are the hydrogens. So it's implied if it's not written there, that means there must be hydrogens attached, because we know carbon always has to have 4 bonds. So know how to write line angle drawings or full structural drawings for cycloalkanes. To name cycloalkanes, you're going to count the number of carbons in your ring and add the prefix cyclo to your name. So in this example here, I have a line angle drawing. Again, every angle represents a carbon. So I'm going to count how many carbons are in here. I have an octagon, so I have 8 carbons. So it would be octane if it was a straight chain alkane. But because they're attached in a ring, it's really important that I write that prefix cyclo. So I have cycloalkane would be the name of this compound. This chart shows the names of some different cycloalkanes. The first one we have is cyclopropane. Prop again means we have 3 carbons, so how it's drawn as a cyclo. This is my condensed structural formula showing the carbons are attached in a ring, or the line angle drawing, you just draw a triangle. Cyclobutane, again the but means we have 4 carbons, which is the one we saw on the previous example. So we have 4 carbons in a ring in the square formation as my line angle drawing. Cyclopentane, again, pent means we have 5 carbons, so we could draw a pentagon as the line angle drawing, or the condensed structural showing me my carbons and hydrogens. And then cyclohexane, hex means 6, so we have 6 carbons in my ring formation, or I could draw a hexagon if I asked for a line angle drawing. So we can also name cycloalkanes when they have groups attached to them. If you only have one group attached, as in this compound below here, you don't have to show the location of the group. So when we had straight chain alkanes, you had to show the location so the group was attached to the smallest carbon in the parent. In this one, we could always just assume this might be carbon number 1. So in my parent, I've got a total of 5 carbons. So I name my parent as cyclopentane for those 5 carbons. And again, the cyclo tells me they're attached in the ring. Now I name my group as I've had before. That's called a methyl. So in this case, it's not required to put the number 1 attached in the front. It's just assumed with only one group, that's going to be your carbon 1. Now, if I have more than one group attached to my cycloalkane, I need to show the location of all those groups. And I'm going to count my carbons so that the smallest numbers are where I'm going to get those groups attached. So in this one, let's look at our parent, is we have 6 carbons, and I want one of those groups to have the smallest number. So I can assign 1, either one of those CH3s I could assign as number 1. 6 carbons is going to give me cyclohexane as the parent. And then my groups, I have 2 methyls, so I have dimethyl cyclohexane, and then they're located at carbons 1 and 3. So I have 1, 3 dash dimethyl cyclohexane for the name of this compound. Name the following compounds. The one on the left, we have 3 carbons in our ring, and it's a ring, so we write cyclo. 3 carbons, we have prop. It's an alkane, so we have cyclopropane. Our group attached is called a methyl, so we put methyl cyclopropane. No number is needed because we're assuming where the methyl group is attached, that's carbon 1. The compound on the right, we've got 5 carbons in our ring, so the parent is called cyclopropane. And we have this bromine attached, and bromine as a group is called bromo. So we have bromocyclopropane. Name this compound. So we're going to look in our ring that we have 6 carbons in our ring. So the name of the parent is cyclohexane. And then we have some groups attached. We have an ethyl group, and we have a methyl group. So we want to put them in alphabetical order. So ethyl comes before methyl. And then we want to show the location of where our groups are attached. And so when you're having groups attached in a ring, you're going to pick that one of the groups is going to be carbon 1, and in this case the other group is going to be at carbon 2. We want to pick that alphabetically they get the smallest number. So carbon 1 is going to be where ethyl is attached, carbon 2 is going to be where methyl. So in our ring we can count clockwise or counterclockwise, so our groups get the smallest number. So carbon 1, we have an ethyl, and at carbon 2, we have a methyl. So the name of our compound we have is 1-ethyl-2-methyl cyclohexane.